You think you know linear equations, but the question is, do you really know it? Let's find out. Let's go. Welcome to the very first episode of 2 School 4 Cool with your boy, Davey Sai. I'm a big believer, regardless where you are, what your current circumstance is, absolutely everyone deserves good education. So if you find value in this video, please smash that subscribe button, click that like button so it reaches out to more people that will find value in this video, and also click that bell notification so you get notified for future videos. Since it's our first lesson, what other equation would I actually potentially teach you other than the linear equation, the first powered function? Without further ado, let's dive into it. So the first type of linear equation is a horizontal line. So how do you know when you see a question whether it's a horizontal line or a different type of linear equation? So if the question is written as y equals to question mark, for example, y equals to 8, and you do not see the x variable behind the 8, you know 100% that it is a horizontal line. So how do you graph such a sketch like y equals 8? You locate 8 on the y-axis on the Cartesian plane, which is currently here. Then you grab your ruler and voila, there you go. That equals y equals to 8. So how do you analyze such a sketch? Well, let's just say x currently represents time. So if you work at McDonald's, guys, no offense Macca's workers, and you get $8 an hour, hopefully it is only it's per hour and not per day, for example. And if you work for 2 years, you still get $8 per hour. You work for 3 years, you get $8 per hour. 4 years per $8 per hour. That means your salary is never going to change if Y is currently representing your salary at McDonald's. So that's how you analyze it. So if we talk about gradients, what is the gradient of this graph? Well, obviously it is 0. In our next lesson, we will discuss about gradients, but if there is no x variable, it means that the gradient is 0. Because another way we can write this question is if we were to introduce an x variable, it will look like this. So that's why the x is inexistent right now, because 0 times x is 0, leaving the 8. So all linear equations is generally written as y equals mx plus c, where c is obviously your y-intercept and m is your gradient. So if your x is not there, it means that your gradient is 0. So you can clearly see if a person was to walk across this line, it will be a very flat stretch. So the gradient is 0. You have just mastered a horizontal line. So how do you know when you see a question on an exam paper or a test paper whether it's a vertical line or not? So if the equation is written as x equals question mark, for example, if x equals to 3, and you do not see the y variable, you know for sure it is a vertical line. So how do you graph a graph like this, x equals 3? Well, you locate 3 on your x-axis on your Cartesian plane, you grab your ruler, and then you draw a line straight through that point, and there you go. We have just sketched x equals 3, which is a vertical line. So what's a real life scenario of where people use vertical lines? So for example, if there's a builder that wants to build a vertical wall from 3 meters from the fence, they will locate 3 meters from the fence, pinpoint that point, and start building the bricks upwards from that point. And that is a real life scenario of a vertical line. And what is the gradient of a vertical line? Well, the gradient of a vertical line is undefined. So anything that drops vertically, it's actually undefined. So hopefully things don't really drop vertically and could be potentially deadly. The second type of linear equation is a diagonal linear line. So how can you tell when you see a question whether it's a diagonal linear line or a horizontal or vertical? Well, if the question is written in the y equals mx plus c format, it doesn't have to be in this format. It could be in another format, which I'll show you later, and it still might be a diagonal line. But if it's written in this format, for example, if it's y equals a 2x, so if there's a coefficient in front of the x variable, you know it's definitely going to be a diagonal linear line. So this is regardless if there is a c value that is not 0. For example, if c equals to 3. So how do you sketch an equation like y equals 2x plus 3? Well, all linear lines and other graphs that have intercepts, you have to provide the intercepts on the sketch unless they state that they're not required. So unless the domain restricts that as well. So we'll get to domain and ranges in another lesson. So let's start with the y-intercept. I know many of you guys might know that the y-intercept is 3, but how do you find a y-intercept? So regardless what graph you ever sketch in mathematics, to find y-intercepts, you always have to let x equal to 0. So if you let x equal 0 and you go y equals 2 times 0 plus 3, well, 2 times 0 is 0. So 0 plus 3 is you're going to be left over with 3. So your y-intercept equals to 3. So how do you locate that point? So you go to your y-axis and you locate 3. And how do you do the x-intercept? Well, to find the x-intercept, you have to let y equals to 0. So if you let y equals 0 in this case, you bring 3 over first, and currently there is invisible times in between the 2 and the x, and the opposite of times is divide. So your answer is negative 3 over 2. But all answers, if you have the option to, mixed fractions is always better than improper fractions, especially for answers. So I would definitely write it as negative 1.5. So mixed fractions better than improper fractions. Well, if someone asks you, how many friends have you lost today? Instead of telling them that you've lost 3 over 2 friends, which they have to think about, and that's probably why you've lost friends, and you tell them, today I've lost 1.5 friends. Straight away they know what you're trying to say. So how do you locate negative 1.5 on your x-axis? Well, you go to the x-axis and you find negative 1.5. Then you grab your ruler out. Your sketch will always be better than mine. A bit tricky. And there you go. You sketch straight through that point, and that is y equals to 2x plus 3. And you can see that it's diagonal. The gradient is 2 in this case. And the only extra thing that we might do is write the intercepts in coordinate points. There you go. That's a diagonal linear line. So another type of diagonal linear equation, just like how I mentioned before, is when it's not written in its y equals mx plus c format. So for example, if the question is written as 2x plus y equals to 4, for example, you know and you can see that there's a coefficient in front of the x variable, it's definitely going to be diagonal. So if the question was written as x plus y equals 4, that is still a diagonal line because the coefficient in front of x is 1. So the only time you will not be a diagonal linear line is when the coefficient in front of x is 0, and therefore you wouldn't even see 0 because 0 times x is 0. So let's go back and focus on 2x plus y equals to 4. So if the question literally is just asking you to graph, You don't need to care about the gradients if they don't ask for the gradients. It doesn't matter the format the linear equation is written in. You just find the intercepts. So if you were to find the x-intercept first, in this case, you let y equal to 0. And as I've mentioned before, the only way to find x-intercepts, regardless of the graph, is to let y equal to 0. So if y equals to 0, and then you're just going to be left with the 2x, the invisible sign in between the 2 and the x is times, and the opposite of times is divide. So it'll be 4 divided by 2, which is 2. Let's locate that on the x-axis. So 2 is there. So clearly, currently, the x-intercept is 2. How about the y-intercept? Y-intercept, you let x equals to 0, and you guys know that strategy will never change. And sometimes when the equation is not written in its y equals mx plus c format, it might be potentially easier. And let's see in this case whether it is. Because 2 times 0 is already 0, so y equals 4. How nice is that? Super nice. So let's locate 4 on the y-axis because this is y-intercept. Intercept means it will cut through that point on that axis. So 1, 2, 3, 4, we locate that. And then we grab the ruler out. And you draw a line straight through those 2 points. And there you go. We just have sketched 2x plus y equals to 4. If you were to find the gradient, and if they ask you, let's just say in another part, what is the gradient? Well, you have to rearrange the equation, bring the 2x to the other side, and there you go. You can see the gradient's actually -2. So if a graph ever starts high and ends low, just like in this case, you see the graph starts high and ends low, you know the gradient is negative. What happens if the x-intercept and y-intercept are at the same position? So you will not be able to use the x-intercept, y-intercept graphing method to graph the linear equation. So of course, this is still going to be a diagonal linear line. For example, if it's y equals 2x. So this case, if you were to find the y-intercept, it's going to be 0. And we can prove that by letting x equal to 0. And you get 0 right there. If it's cutting through the origin, and everyone should know, the origin is where the sketch cuts through 0, 0, the center of the Cartesian plane, you know that the x-intercept is also going to be 0. So let's prove that as well. X-intercept, let y equal to 0. Everyone knows my writing is the neatest thing in the world. So if you bring that over, 0 divided by 2 is going to be 0. So therefore 0. So what strategy do we have to use in this case? I call this the rise of a run graphing method, or there is another option as well if you don't like it. So if you guys grab the gradient, the 2, and you divide it over 1. So your rise is 2 and your run is 1. So everyone should know gradient is rise of a run. We'll get to that in another lesson as well. So what this means is every time you run by 1 from the starting position, you run by 1, you'll rise by 2. And there you go. We grab the ruler out. And there you go. You just sketch y equals 2. So what's another way of sketching a y equals 2x equation? So we call this a y equals mx format equation without using the rise of a run method. Well, we just have found out that the x-intercept and the y-intercept is cutting through the origin, which is 0, 0. If you don't like the rise and run method, all you have to do is sub in an extra point. All sketches, like linears, you need bare minimum 2 points to prove the graph is actually sloping and flowing in that certain direction. So what point should you choose? Well, I would choose x equals to 1. If you're not going to choose a random number, you're going to make your life a lot easier. So if you sub in x equals 1, you actually get 2. So therefore, at 1, it equals to 2. So you go to 1, which is here, and 2 is here. You put a point through there. You grab your ruler out. And there you go, guys. That's y equals to 2x. So let's quickly recap everything. There were our horizontal lines, which is y equals question mark. Our vertical lines, x equals question mark. Our diagonal lines that might be written in the y equals mx plus c format. So just remember, when there's a coefficient in front of the x that is not a 0, you know that you're definitely going to be diagonal. And there is also the sketches where the y-intercept and x-intercept is 0, where you will need another point to sketch the linear line. Well done for making it to the very end of this video. Hopefully you feel more confident graphing linear equations now, or potentially mastering it. Glad you guys found value. Don't forget, you can still be cool and be good at school. See you next time, guys. Peace out.